अच्छा, so this one is electrophoresis. और इसके अंदर क्या होगा? इसके अंदर होगा कि it's similar to electrophoresis is similar to it's very similar to chromatography. You do electrophoresis of amino acids. So here you have an amino acid. An amino acid is a molecule. It's a basic building block of we did this in organic chemistry. It's a basic building block of proteins. So you've got amino acids have an amine group, which is this one, and they have a carboxylic acid group on one side. And in the middle, they have a hydrogen on one side, and there is an R group on the other side. Okay, now, and that R group varies. Okay, that R group is different for different amino acids. So, जो भी variation है, that happens with this R group. That's a typical amino acid. Now, if you look at an amino acid, you would notice that it's got an acid group. Okay, so that is going to behave as an acid, and it would lose H+1 ions or produce H+1 ions, specifically the H+1 at the end. And it's got a basic group. Why is it basic? Why is this basic? Because it's got a lone pair, and the N lone pair is capable of accepting H+1 ions. So that particular part is going to be basic, and it will be able to gain H+1 ions. So that's one very unique property, that it can behave as an acid, it can behave as a base as well. So it can kind of do both things. Or कुछ examples कर लेते हैं. Amino acids, the only thing is that the R group keeps changing. So यहाँ पे ना there's going to be a list of, ये अच्छी list है. So there's this list of amino acids, and इसको copy कर लेते हैं. Let me copy this. So total 20 amino acids होते हैं, 19 to 21 amino acids in the human body. So here are a few examples of some of them. Okay, so that's kind of an exhaustive, the most common ones. Okay, so that's a list of amino acids, and as you can see, कि हर case में what is different is the R group. Like if you look at alanine, jiska symbol ALA, the only difference is that there's a CH3, that's your R group. If you look at this other one, the R group is kind of different. It's this is valine. This one is leucine. Okay, every time the R group is different. Okay, there's one instance where there is an H, so that's methionine, etc., so on. So lots of different amino acids. Okay. Now remember, amino acids can form zwitterions. What is a zwitterion? A zwitterion is that it can lose H+1 and it can gain H+1. Both things can happen. So a zwitterion is an ion that has no overall charge. So it has no overall charge, but it has regions of both positive and negative charges. So it's got regions of both positive and negative charges. So each amino acid can form a zwitterine. So I'm going to take this amino acid, and what will happen is, we know that there's an acid group and there's a basic group. So what can happen is that the acid would lose H plus 1 ions. So if it ends up losing H plus 1 ions, it's going to form an O minus 1 ion. So that the carboxylic acid would turn into a carboxylic ion. And the base over here can end up gaining H plus 1 ion. So that H plus 1 will get attracted to the lone pair, and it would end up forming a dative bond. So this side gains, one side loses. And one side is negative. The way to write this is, if I were to write this, this is on one side you have CO minus 1 ion. On the other side you have NH3 plus 1 ion. On one side you have the R group, or top pinna, there is H. ये clear है सारों को? Is this clear?
Yes, sir.
Yes, sir.
Acha, so ye, that's what a zwitterine is. Then there's another thing, how would, so remember, they're going to ask you to draw a zwitterine for any amino acid. All you have to do is isko -1 kar do, this one becomes NH3 plus 1, and that's it. The other thing that they're going to ask you about is amino acids would behave differently in a base and would behave differently in an acid solution. So if I have an amino acid, so the amino acid, it behaves as a base in acid solution. And they might ask you to write an equation for that. So the amino acid behaves as a base because it can do both things. So agar solution mein acid hoga, if the solution has a lot of H plus 1 ions, so they're going to ask you for the equation, what will happen to it. So if the solution is acidic, that means it's got a lot of H plus 1 ions. So in the presence of H plus 1 ions, the base and its lone pairs will be the ones that would be gaining H plus 1 ions. So the product is going to be, that it would form on this side, it would become NH3 plus 1 because the N would end up gaining H plus 1 ions. The carboxylic acid will not be able to lose the H plus 1 because it's an acid solution. There are already a lot of H plus 1 ions, so it would be very hard for it to actually lose the H plus 1. ठीक है, ये चीज clear है? Is this clear?
Yes, sir.
और फिर इसका opposite होगा कि the opposite is if you add an amino acid in a basic solution, then it would behave as an acid. So it's going to behave as an acid in a basic medium. ठीक है, तो गलत कर दिया, एक सेकेंड, बल्कि ऊपर वाले को चेंज कर लेते हैं, उसी में करेक्शन कर दी, this one. अच्छा, in basic medium. तो basic medium में क्या होगा कि there's going to be a lot of OH ions. So if there are a lot of OH ions, तो the N will not be able to gain H plus 1 because there is no H plus 1. Okay, so the NH2 would not be behaving as a base. Instead, the carboxylic acid would be the one that would be losing a lot of H plus 1 ions because the OH ions will be attracting them. So ये वाली side जो है ना, that would remain NH2, nothing happens to it. And this side turns into CO minus 1 and water. ठीक है, so इसको भी यहाँ पे शो कर देते हैं कि ये जो है ना, ये 1 second यहाँ पे जाके अटैच हो रहा है. So is this idea clear? ये clear है सारों को?
Yes, sir.
अब इससे अगला जो है ना, वो है electrophoresis. ठीक है, तो मतलब ये क्वेश्चन आएंगे बहुत बेसिक सिंपल से क्वेश्चन. They'll give any amino acid, either make a zwitterine, अच्छा, isoelectronic point, let me just see if they still मतलब वो वेरिंग पीएच का तो हमने देख लिया, ठीक है. The effect on that will not be tested, ठीक है. Isoelectric point, ठीक है. I'm going to talk about the isoelectric point now. So the isoelectric point is, अच्छा ये point समझने की कोशिश करना, what is this point, and that's linked to this thing. अच्छा, so the isoelectric point, remember this thing, okay, the carboxylic acid in basic medium, it loses the H+1, and the amine in acidic medium would gain in H+1 ions. So somewhere in the middle, तो isoelectric point है कि it's the point at which Zwitter ions are formed. ठीक है, that's the point. And it's the pH at which Zwitter ions are formed, which means the amino acid would be behaving as both things. So here's an amino acid. Amino acid, it's got a carboxylic acid group, the acid group, and it's got a basic group. और ये R है. अच्छा, now the thing is कि हमने क्या है कि भाई, if the solution, if the medium is too alkaline का मतलब है there's a lot of OH ions around it, so there's a very bright chance that the H+1 over here would be lost, right? Vice versa, I told you that if the medium is too acidic, if there's a lot of H+1 ions around, ठीक है, so the lone pair would be gaining H+1, right? तो इसका मतलब है कि अगर pH greater than 7 होगा, if it's basic, तो ये काम होगा जो ऊपर हो रहा है. And if the pH is less than 7, तो ये वाला काम हो रहा होगा, ठीक है. That means कि in the acidic medium, the amino acid would look like this. Okay, the amine would be gaining H+1. दोनों काम कब होंगे? दोनों काम तब होंगे. अच्छा, दोनों काम कब होंगे? Both things would happen only if there is H+1 present and there is OH ions present as well. If both are present in equal quantity, and that is pH 7. ठीक है, pH 7 के ऊपर, I mean somewhere in the middle, it's going to form a zwitterine. ये बात भी clear है?
Yes, sir.
ठीक है, so somewhere in the middle it's going to form a zwitterine. But the thing is, it's not going to be exactly 7. मतलब hopefully pH 7 के करीब होगा. वो मैं उस पे आता हूँ कि why is it not exactly 7? So the point is that if you add too many OH ions in the solution, this side would lose H+1. If you add too many H+1 ions, this side would gain H+1 ions. If you add both of them, that's neutral conditions, so it would form a zwitterine. But the thing is, okay, the strength of the base and the strength of the acid can vary. ठीक है, maybe the acid is very strong. इसका मतलब है कि ये वाली जो साइड है, this acid is really strong, and this base is very weak. ठीक है, the two things can have different strengths. So let's assume कि जो basic side है, that's weak, and the acidic side is really strong. अच्छा, उससे मसला क्या होगा? मसला ये होगा कि if it's really strong and if it really wants to lose H+1 ions, तो you don't need a lot of OH ions. मतलब OH ions इतने ज्यादा जरूरत नहीं है क्योंकि उससे तो H+1 वैसे ही लूज कर जाना ना. You're planning to make it into a zwitterine, right? So it would lose H+1 anyways. I mean, you don't need to add too many OH ions. ये बात समझ आइए?
Yes, sir.
और अगर बेस जो है ना वो बहुत वीक है, तो that means it's not gaining H+1 that strongly. So you would have to add a lot of H+1 ions ताकि वो zwitterine बन जाए. It's able to gain H+1, right? So the point I'm trying to make is कि इसका मतलब है कि zwitterine जो है फिर pH 7 पे नहीं बनेगा. It's going to be slightly, it's going to be, the pH would be slightly, it has to be kept slightly acidic, क्योंकि तब जाके zwitterine बनेगा. क्योंकि मसला ये है कि वो the base is not gaining H+1 ions, so you would have to add extra H+1 ions. ठीक है, you would have to add extra H+1 ions ताकि ये पॉजिटिव आयन बन जाए. वो नेगेटिव आयन बनने के लिए वैसे ही तैयार था क्योंकि it was a strong acid. So remember, every time in every amino acid, the strengths are going to vary. And if the strengths vary, the zwitterine will not be formed at exactly pH 7. It would be formed somewhere around pH 7. Sometimes it would be formed at a slightly acidic pH. Sometimes it's going to be formed at a slightly basic pH. ये clear है?
Yes, sir.
Yes, sir.
तो इसको मैं करेक्ट कर लेता हूँ कि the isoelectric point is around pH अच्छा, the isoelectric point is around or near pH 7. ठीक है, that's the point जहां पे it will form a zwitterine. And it varies because of the difference in strength of acid and base group. तो एक एग्जांपल ले लेते हैं कि let's think of glycine का देख लेते हैं. Glycine isoelectric point. इसके ऊपर मैं बता देता हूँ क्वेश्चन किस तरह का आएगा. I said the isoelectric zone of glycine extends from approximately 4.5 and its isoelectric point is 6.082. पता नहीं कुछ ज्यादा. इन पे लिस्ट नहीं लिखी हुई. हाँ, pH 5 चलो ये कर लेते हैं. 6 ही दिया हुआ है. So let's talk about glycine. ठीक है, the question would be so the question would be like this, that glycine has an isoelectric point at pH 6. ठीक है, that's the isoelectric point. Glycine is this amino acid. It's got carboxylic acid and NH2 on one side, and R group जो है ना उसका, I think that's H. पता नहीं, correct me if I'm wrong, but I think glycine is H. अच्छा, so he would say कि the question would state, what is, draw glycine at pH 6.5. अच्छा, so you're being asked to draw glycine at pH 6.5. इसका मतलब है कि for glycine this would be basic. बल्कि इसको पहले मैं पॉइंट को एक्सप्लेन कर लूं कि अच्छा, remember isoelectric point is something that's इधर भी बल्कि मैं equal to के साइन को ना वो approximate का साइन डाल देता हूं, something that's close to 7. So the point is, any pH above the isoelectric point, that would be considered basic. Any pH, any solution that has a pH below the isoelectric point, it's going to be considered acidic. ठीक है, तो ग्लाइसिन की अगर हम pH 6.5 के ऊपर बात करेंगे ना, what would that mean is that that glycine is in a basic medium. ठीक है, so pH 6.5 is higher than the isoelectric point. So for glycine, this is going to be basic. मेरी आइडिया समझ आ रहा है कि मैं इधर फिर से एक्सप्लेन कर दूं. अगर तो OH आयन ज्यादा होंगे तो this would become this would lose H+1. अगर H+1 ज्यादा होंगे तो this would gain H+1. Somewhere in the middle, if both of them are present, it would become a zwitterion. But zwitterion has a specific pH at which it's going to be formed, depending on the strength of the two groups. So that can be considered from the point of view of the amino acid, that could be considered pH 7, or something that would be close to pH 7. So any pH above that, if the solution has a pH that is greater than the isoelectric point, so you're going to consider the solution to be basic. Uske point of view, so from the point of view of the amino acid, any pH that is lower than the isoelectric point for the amino acid, that would be acidic. Is the idea clear?
Yes, sir.
So अगर glycine का isoelectric point pH 6 है ना, that means it's going to behave as a zwitterion at pH 6. If the pH becomes greater than 6, then from the point of view of glycine, that is basic to it. The basic medium में what will happen if it's basic? तो basic का मतलब है कि the OH ions are too many, so the H+1 would be lost, and glycine would look like this. Glycine would end up losing it would end up losing an H+1 and it would form a negative ion. ठीक है, और अगर वो कहता है कि draw glycine at pH, let's say he repeats the question and this time he says draw glycine at so vice versa, if he says draw glycine at pH 5.5, so it is lower than the isoelectric point. So from the point of view of glycine, the medium is acidic now. Or acidic में क्या होगा कि there's going to be too many H+ ions. So the carboxylic acid would not be able to lose. Instead, the amine would actually end up gaining H+ ions. ठीक है? तो ये सारे questions आएंगे isoelectric point पे कि is going to give you an amino acid, he'll tell you the isoelectric point. So if the pH that they're talking about is greater than the isoelectric point, think of the medium as basic. The basic and then the acid would be the one that would lose H+1. And if the medium has a pH that is below the isoelectric point, so you will consider the solution too acidic. And in that case, ammonia would be the one that would, the amine group would be the one that would gain H+1. अच्छा, ये बात clear है सारों को?
Yes, sir, clear.
ठीक है, तो अब आ जाते हैं electrophoresis पे कि so electrophoresis is this thing. It's you take amino acids in a buffer solution. So there's this, usually it's a filter paper. That filter paper is soaked in a buffer solution. It's soaked in a buffer solution. So यहाँ पे ना there is let's say 2 trays. Here's another one. अच्छा, और इसके अंदर ना there is a solution. So the reason you add a buffer solution is you don't want the pH to change. Okay, if the pH changes, the amino acid changes. Okay, pH becomes too basic, or the pH becomes too acidic, so the amino acid would actually change. So what you do is you want to keep the pH constant. So the pH is kept constant, and it's a technique for separating amino acids or analyzing amino acids. So it's for separation, identification, analysis of amino acids, which is very similar to chromatography. अच्छा, इसमें होगा क्या? You'll put a mixture of amino acids over here. So you're going to put a mixture of amino acids over here, and or इधर ना बीच में you'll put 2 wires. ठीक है, there's going to be a battery. I just hold on 1 second. ठीक है, 1 second.